Hello everyone. Today we'll be see the problem of simply supported beam. So this is a problem. A problem, a simply supported beam of 8 meter span carries 3 point loads 100 Newton, 200 Newton and 400 Newton at 2 meter, 4 meter and 6 meter from LHS. LHS means left hand side. Draw SFD and BMD. So this is our beam and RA and RB is the support. RA and RB support. Then 3 point loads 100 Newton, 200 Newton, 400 Newton. 100 Newton load is at a 2 meter distance from left support. 200 Newton load is at 4 meter distance from left support from A to D is a 4 meter distance, and 400 Newton load is at 6 meter from left support, and total span of beam, that is RA and RB, is 8 meter. And from this figure we have to draw SFD and BMD. So our first step is take moment about the point A. Take moment about the point A. So take moment about that point A. While taking moment, sign is considered clockwise, forces are considered positive, anti-clockwise forces are considered negative, and moment means force into perpendicular distance. So there are 1, 2, 3, 4 and 5 forces are available. In that, value of RA is 0 because we are already taken movement about that point A. So value of RA is 0. Then consider second force, that is 100 Newton, which is going in clockwise direction towards A. So RA, so 100 into distance is 2 because RA to 100 distance is 2, so 100 into 2. Then consider second force, that is 200 Newton, which is also going in clockwise direction towards A point. So force, moment means force into perpendicular distance. So force value is 200 into distance A to D distance is 4 meters. So write here 4. Then consider third force, that is 400 Newton, which is also going in clockwise direction. Clockwise direction here. So moment means force into perpendicular distance. So write the value of force is 400 and distance, that is 400 to A distance is 6 meter. 2 plus 2 plus 2, that is 6 meter. So write here 6. Then RB, which is going in anti-clockwise direction towards A. So consider it is a negative sign. So write here negative sign. The value of RB is right here RB, and B to A distance is 8 meter. So write it into 8 here is equal to 0. After calculating 100 into 2 plus 200 into 4 plus 400 into 6, we got an answer of 3400, and minus RB into 8 move towards 0, that is plus RB into 8. So when we divide the 8 to 3400, we got an answer of RB is equal to 425 Newton. So here we calculated the reaction of the B by taking moment about the point A. Then second step is consider summation Fy. So summation Fy means consider algebraic sum of all the vertical forces. So here RA, first force consider RA, the RA which is going in upward direction, so consider plus RA. 100 is going in downward direction, so consider minus 100. 200 which is going in downward direction, so consider minus 200. 400 which is going in downward direction, so consider minus 400. And RB which is going in upward direction, we already calculated the value of RB is, that is 425 Newton, so consider here plus 425 is equal to 0. After calculating minus 100, minus 200, minus 400 plus 425 in the calci, we got an answer of minus 275. So that 275 moved towards 0, we got an answer of RA is equal to 275 Newton. So this is the value of reaction of the A. So this is about the RA and RB. Then next step is calculate the values of shear force. Shear force at first consider from left side, that is A of left is equal to 0 Newton. Means A of left is 0 means draw one vertical line left of the A, like draw here. Now look left of that line. While looking left of that line, there is no value, so write A of left is 0. The next is A of right is equal to 275 Newton. Means now this vertical line is moved towards right of A. Means you should draw line here. Now you look the left of this line. While we looking the left of this line, we only see a RA force, and RA which is going in upward direction, so consider plus RA. So value of RA is 275. So here we got answer of 275 Newton. The next is C of left is equal to 275 Newton. Means that vertical line is draw left of the C. Like you should draw here or same here. Now you should see left of that line. Where watching the left of that line, there is only RA force, which is answer is 275, and RA is going in upward direction. So consider here 275 Newton. So this is about the C of left. The next is C of right, which is 275 minus 100 is equal to 175 Newton. Means this vertical line is draw right of the C. Means you should draw here line. Now you see left of that the line. While we seeing the left of that line, there are only two forces, RA and C. The RA which is going in upward direction, so consider plus RA, and C which is going in downward direction, so consider minus. So RA's value is plus 275 and 100 which is going in downward direction, so minus 100. So 275 minus 100 means 175 Newton. The next D of left. D of left is 275 minus 100 is equal to 175 Newton. Means now this line is draw left of the D. So you should draw here a same here. Now see to left of that line. While we watching the left of that line, there are two forces, RA and C. The RA which is going in upward direction, so plus RA, that is plus 275, and 100 which is going in downward direction, so minus 100. So calculating these values, we got an answer of 175 Newton. The next is D of right. D of right is equal to 275 minus 100 minus 200 is equal to minus 25 Newton. Means now this line is draw right to the A, right to the D. Means you should draw here right to the D. Now see left of that line. While watching the left of that line, there are three forces, RA, C and D. The RA which is going in upward direction, so consider plus RA. C which is going in downward direction, so consider minus 100. D which is going in downward direction, so minus 200. So that after calculation we got an answer of minus 25 Newton. Then next is E of left, which is also same, 275 minus 100 minus 200 is equal to minus 25 Newton. Means this line left of the E, means consider this line here. Now see that left of that line, while watching that line, left of that line, you see three forces, RA, C and D. RA which is going in plus upward direction, so consider plus. 100 is going in downward direction, so minus 100. 200 is going in downward direction, so minus 200. So after calculating, we got answer of minus 25 Newton. The next E of right. E of right is equal to 275 minus 100 minus 200 minus 400. After calculating, we got answer of minus 425 Newton. Means this line now draw right to the A. Means you should draw line here, right to the A. Now see left of that line. While seeing the left of that line, there are four forces RA, 100, 200 and 400 Newton. So RA is going in upward direction, so consider plus RA. 100 is going in downward direction, so consider minus 100. 200 is going in downward direction, so consider minus 200. 400 is also going in downward direction, so consider minus 400. Like this, plus 275 minus 100 minus 200 minus 400. After calculating, we got answer of minus 425 Newton. B of left is also same, 275 minus 100 minus 200 minus 400 is equal to minus 425 Newton. Here is this B of left, means this line is draw left of the B, like here. And now you see left of that line, there are four forces 1, 2, 3, 4, which is also same. It is plus RA, that is plus 275 minus 100 minus 200 minus 400, which is answer is minus 425 Newton. Last is B of right. B of right is equal to 275 plus minus 100 minus 200 minus 400 plus 425 is equal to 0 Newton. Means this line is now draw right to the B. Should draw line here. Now see left of that line, there are number of forces are 4 plus RA minus 100 minus 200 minus 400 and plus RB, that is plus 425 Newton. So here answer is 0 Newton. In generally simply supported beam, the values of shear force in first value of the shear force is 0 and last value of the shear force is also 0. This is about the values of the shear force. The next is drawing the shear force diagram. While drawing the shear force diagram, first to draw the baseline. Baseline A, C, D, E and B. So value of A of left is 0, means consider this value here. Then second, A of right is plus 275. The plus value should be drawn above the baseline here and minus value should be drawn below the baseline. So A of right is plus 275 Newton, means you should draw one vertical line and this vertical line about the 275 Newton. Then next, C of left is 275 Newton and C of right is 175 Newton. You should draw vertical lines. This dotted line shows 175 Newton value and vertical line shows 275 Newton, means this 275 Newton value is from top to baseline and 175 value is from this distance is regarding the 175 Newton. Then next is D. D of left is plus 175, means draw one vertical line of the 175. Then D of right means minus 25, minus should be drawn below the baseline. This is minus 25. Then next E of left is minus 25 and E of right is minus 425. The minimum value of minus 25 you should draw from dotted line. This is minus 25 and bigger value of minus 425 should be draw vertical line or joint line. This is a minus 425 and last is B of left is minus 425. This is about the minus 425. The next step is join AC, CD, D and AB. So first is 0, so start here from 0, then 275, come here 275, then C of left is 275. In between A and C there is no load, so join with horizontal line. Then next come top to here, bottom. Then between C and D there is also no load, so join with constant line or horizontal line. In D and E is also no load, so join with horizontal line. E and B is also, in between E and B there is no load, so join with horizontal line. This is about the shear force diagram. Then next is calculate the values of bending moment. Here sign is considered as upward force are considered positive, downward force are considered as a negative. First we see all the values of bending moment. First value of bending moment of A is equal to 0 Newton. Write somewhere bending moment of A is equal to 0 Newton. Bending moment of C is 275 into 2 is equal to 550 Newton. So how is it come? So bending moment of C is you should look left of the C or right of the C and consider the side whose minimum number of force are minimum are available. Means consider left side there are only one force and in right side there are 1, 2, 3 forces. So number of minimum force are in left direction. So consider left direction, that is only RA force which is in going in upward direction. So consider RA. So RA's value is plus RA, that is 275 and distance is 2. So after calculating 275 into 2 we got an answer. Then next come bending moment at D. In bending moment of D, the left of the D there are two forces and right of the D there are also two forces. So choose any one direction. Suppose from taking we taking from the left side the RA which is going in upward direction. So plus RA, that is plus 275, and A to D this distance is 4. So 275 into 4. Then 100 is going in downward direction. So minus 100 into this distance is 2. So that calculating we got an answer of 900 Newton. And last is next is bending moment at E is equal to 425 into 2 is equal to 850 Newton. Means bending moment of E, here E point. In left of the E there are number of forces are 1, 2, 3, and right of the E there are only one force. So choose the right side of the E because there is minimum number of force in right direction. So consider only RB which is going in upward direction. So RB's value is 425 into distance from B to E is 2. So after calculating we got an answer. Then last is bending moment of B. In left of the B there are number of forces are 4 and right there are 0. So consider here right side. So answer is 0. So this is about the bending moment values. Then next bending moment diagram. For drawing bending moment diagram, first to draw one baseline where the point of this A, C, D, E and B. Then bending moment of A is 0. Bending moment of C is 550 Newton. So draw vertical line above the baseline of 550 Newton. Then bending moment of D is 900 Newton. So you should draw vertical line above the baseline of 900 Newton. The next bending moment of E is equal to 850 Newton. So draw vertical line above the baseline of bending moment of A is equal to 850 Newton. And last is bending moment of B is equal to 0. So the no vertical line should be draw here. So now join AC, CD, DE and EB. In between A and C there is no load. So join with inclined line AC. In CD is also no load. So join with inclined line. In D is also no load. So join with inclined line. And EB is also no load. So it is also joined with inclined line. So this is about the bending moment diagram. This is our first problem. Then second problem is a simply supported beam of 5 meter span is subjected to UDL of 20 kilonewton per meter over 3 meter length from left support. Draw SFD and BMD. So this is a beam of RA and RB support with span of the beam is 5 meter. The next is subjected to UDL of 20 kilonewton per meter. Means there is a UDL load of 20 kilonewton per meter over 3 meter length from left support, means 8 to up to 3 meter there is also this UDL load, uniformly distributed load. Okay, and remaining distance is C to B is 2 meter. Now we have to draw shear force and bending moment diagram. For drawing this diagrams, first we have to calculate the values of RA and RB. For calculating RA and RB, our first step is take moment about the point A, that is summation of moment of A. In summation of moment of A, RA which is going in upward direction, the value of RA is 0. Then 60, how is 60 is come? We know the UDL value is 20 kilonewton per meter. This UDL value is converted into point load, means here 20 into 3. 20 into 3 is 60. Like here, draw is point load. This point load, which is at center of that UDL, which is acting at center of the UDL. So 20 into 3, it is 60, and 1.5 means this distance to A distance is half of that UDL, that is total distance of UDL 3 meters. So the half of that UDL distance is 1.5. So it is about 60 into 1.5. Again I told you 60 comes from UDL value is 20 and UDL's distance is 3. So 20 into 3, 60, and 1.5 is come from while we converting UDL into point load, that point load is center of that UDL distance. Means suppose the UDL distance is 3 meter, so this point load is at center of that 3 meter, that is 1.5 meter. So from this point load to the RA, the distance is 1.5. The next force is RB. The RB which is going in anti-clockwise direction. So consider minus RB, and B to A distance is 5. So RB into 5 is equal to 0. After calculating 60 into 1.5, we got answer of 90, and move RB into 5 towards the 0. So RB into 5, and after dividing 5 to 90, we got answer of 18 kilonewton. Then second is summation Fy. Summation Fy is equal to 0, means consider all the vertical forces. Here RA which is going in upward direction, so consider plus RA. Then this point load means 60 kilonewton. Already we converted UDL into point load. So this point load which is going in downward direction, so minus 60, and RB which is going in upward direction, so plus 18 is equal to 0. So after calculating, we got an answer of RA is equal to 42 kilonewton. The next step is calculate the values of shear force. So first value A of left is 0 kilonewton, means you draw vertical line left of the A. Look, left of that the line, vertical line, there is no force, so A of left is 0. The next A of right is 42 kilonewton, means this line is now draw right to the A, means you should draw here line. Now Now you see left of that line there is only one force, which is RA force, and that RA force is going in upward direction. So consider the value of RA only. So value of RA is 42 kilonewton. So right here 42 kilonewton. The next shear force at C is equal to 42 minus 60 is equal to minus 80 kilonewton. Means now this vertical line is drawn on the directly on the C. Here is no need to draw left of the C and right of the C, because in C there is no point load. If the point load is present, then you should draw left right of that point. In C there is no any vertical point load, so there is no need to draw C of left and C of right. While when we calculating C of left and C of right, the answer is same. So there is no need to draw so no need to calculation of C of left and C of right. Only consider shear force at C. Means this line should be drawn directly on the C. Now we look left of the C, there are two forces RA and UDL. The RA which is going in upward direction, so that is 42 kilonewton, and UDL which is already be converted into point load, that is going in downward direction. So write minus 60 because 20 into 3 60. So this is a minus 18 kilonewton. The next is B of left. It is also same, 42 minus 60, that is minus 80 kilonewton. Means this line is draw left of the beam. Means you should draw here or here or here, right? Draw anywhere like up to this, up to the C. So you should draw, consider same line, because this is the left of the B. Now you see left of the line there are same forces, that is RA and UDL. So same answer is come, that is minus 18 kilonewton. And last is B of right, plus 42 minus 60 plus 18 is equal to 0 kilonewton. Means this vertical line is draw right to the B. Right to the B means you should draw here. Now look left of that the line, while seeing left of that line there are three forces, that is RA, UDL and RB. The RA which is going in upward direction, so consider plus RA. UDL which is going in downward direction, so consider minus, and RB which is going in upward direction, so consider plus. Means plus 42 minus 60 plus 18. So the answer is 0 kilonewtons. And next step is to draw shear force diagram. So first draw baseline ACB. The value of A is 0, then value of A of right is 42 kilonewton, which is plus. So draw vertical line above the baseline. Then value of C is minus 18, so draw below the baseline vertical line. B of left is also minus 18. Now join AC. While joining AC, in between A and C, there is a UDL. When UDL is come, then it is joined with inclined load, and in between C and B there is no load, so it is joined with horizontal line. So this is about the shear force diagram. Now one more point is come here. While any shear force diagram converted its sign, that is while it is moving from positive sign to the negative sign, this line is come from positive to the negative, and this point is called as a maximum bending moment. Means this point having maximum bending moment than the A, C and B. When maximum bending moment is come, that is when shear force diagram changes sign, its sign, that is when it come from positive to negative, and that point is called as a maximum bending moment. The meaning of the maximum bending moment is the value of this point is more than A, C and B. So our first now we calculated the value of x. How maximum bending moment is when shear force diagram changes its sign positive to negative or negative to positive, then it is called as a shear force or maximum bending moment. At this point bending moment is maximum. Means now we draw same figure, that is we draw this same figure A, B, C. So should draw same figure here again. Then consider A to B. This distance is x meter and we already know A to C is 3 meter. The formula for calculating distance x is that x is equal to maximum shear force divided by UDL load. Here maximum value is plus, that is 40 kilonewton. So write 42 divided by 30 which is came from the UDL's original value, that is 30. So okay, so after calculating that we got answer of x is equal to 1.4 meter. The next step is calculate bending moment sign values. The sign is for that upward force is considered plus, downward force consider negative. So bending moment of A is equal to 0 Newton, bending moment of C is equal to 18 into 2, that is 36 Newton. Bending moment of B is equal to 42 into 5 minus 60 into 3.5 is equal to 0. Generally in simply supported beam, first value of bending moment of and last value of bending moment is also 0, always 0. So our next step is calculate the values of maximum bending moment. So maximum bending moment means now we have to calculate the value of this point, and this point we call as a D point. So now we have to calculate the bending moment of the D point. For calculating bending moment of D, we redraw this figure again. This figure is draw up to A to D because here we consider bending moment of D, and so only we drawing A to D. There is no need to draw full figure. It is only you should draw only which point you have to calculate up to minimum number of forces are available. So we already calculated A to D distance is 1.4 meter. This is the RA point. A to D there is a UDL load, and value of UDL is 20 kilonewton per meter. So we have to calculate maximum bending moment at D. So while calculating maximum bending moment of D, so this is the point D, and while we looking the left of the D, there are only RA and UDL. So consider these values. The RA value is 42. The A to D distance is 1.4. 42 into 1.4. Then that UDL is converted into point load. That UDL is converted into point load. Well, means this force is going in downward direction. So consider minus 20 into 1.4. This is a 20 into 1.4. And distance, now distance we want a distance from this point load to the D. So 1.4 divided by 2, because this point load is always at center of the UDL. So 1.4 divided by 2. So after calculating this all this value, we got maximum bending moment at D is equal to 39.2 kilonewton, which is greater than the bending moment of A, bending moment of B, bending moment of C. So next step is to draw bending moment diagram. For drawing bending moment of diagram, first to draw baseline, the baseline A, D, C, B. Value of bending moment of A is 0. Value of bending moment of D is 39.2 kilonewton. This is 39.2 kilonewton. This is about the value of bending moment of C, and bending moment of B is also 0. Now we should to draw AD. While joining AD, in between A and D there is a UDL load. In between A and D there is a UDL load, so it is joined with parabolic curve. This is a parabolic curve. D and C always also having UDL, so it is also joined with parabolic curve. And C and B there is a no load, so it is joined with inclined line. So this is about the bending moment diagram. In this problem, one new concept is come, that is a maximum bending moment. And maximum bending moment means the shear force diagram changes its sign positive to negative or negative to positive. That point is called as the maximum bending moment. The meaning of the maximum bending moment is that the value of that point is greater than the other points. So this is about the problem of shear force and bending moment diagram. Thank you.